In this course, we presented the SparseLand model, covering a lot of ideas and results around it. However, we did not cover all the available topics in this field, simply because of lack of time. We now turn to describe what we have missed, and also try to give you a taste of the current and future work in this arena. When I'm looking at the accumulated knowledge in the field of SparseLand, I identify 3 layers of activity. The first has to do with the model itself and variants of it. The second focuses on the theoretical foundations that this model needs so much. And the third refers to the applications. The work on SparseLand still spreads in all these 3 branches, as we describe next. When I presented SparseLand, I told you that it is merely one step in a long evolutionary process of models that struggle to serve signals better. There is no reason to believe that this evolution stops here. Indeed, various attempts have been made in the past decade to go beyond SparseLand, take the good from it, throw the rest, and invent new models. These attempts led to ideas such as forcing connections between the non-zeros in the representations via the Boltzmann machine, applying pursuit on groups of signals together while forcing some ties between them. A massive body of work explored low rank as a structure in matrices that resembles the sparsity of signals. We mentioned briefly the co-sparse analysis model. We touched on patch modeling, but we did not mention the recent work that ties this to the convolutional sparse coding model. Further work should strive to improve the SparseLand model because this is the only way to create the next leap in performance in applications. The theory that stands behind SparseLand model is rich and impressive. And in this course, mostly in the first part of it, we exposed portions of it. We did not mention results that use the RIP instead of the coherence to derive guarantees for pursuit algorithms. We hardly touched on the subfield of compressed sensing. We did not dare bringing average case performance analysis since it is so complicated. We did not mention other well-justified algorithms with their guarantees such as cosamp, subspace pursuit, IHT. And we only pointed briefly to papers that dared to look at the dictionary learning problem from a theoretical point of view without really describing their ideas. On all of these fronts, and especially the last one, the work is still very much on. A better theory, beyond its elegance, could help in better shaping the model and leading to better algorithms. And then there are the applications and the tools that serve them. New pursuit algorithms, better dictionary learning methods, and more are critical, widely influencing whatever we do with SparseLand. We keep seeing new applications entering the game that we have not mentioned in this course, such as recognition, image synthesis, treating of Poisson data, and more. We will see much more of these in the coming years now that the SparseLand model is better understood. I would like to conclude this course by presenting few of our recent activities on SparseLand. Starting from the model as described in this course, we moved to a special case of it called CSC, convolutional sparse coding. We developed a completely new theory for it that very much parallels all that we have covered in the first course while redefining the notion of sparsity to become local. From there, we continued by suggesting a multi-layer version of this model, and this way getting a theoretical tie of this model to convolutional neural networks. Thus, this work visited all the 3 layers I mentioned above. These are the papers covering the above described work written by Yaniv Romano, Vardan Papian, and Jeremiah Sulam. In a different work, we targeted the dictionary learning problem, and more specifically, their limitation to operate with small patches. We developed the trainlet, an alternative algorithm that is based on the double sparsity idea, while being able to operate effectively on complete images. In a later activity, we took this method and exploited it for inpainting of face images. I mapped this activity as belonging to the applications. These are the relevant papers as written by Jeremiah Sulam. A third activity that I would like to tell you about has to do with graph signal processing. If the data is given as values on nodes of a graph, how do you use SparseLand? Such a discussion emerged in the literature several years ago, and together with Yael and Kelevsky, we started working on our own way of bringing SparseLand into this domain. Our algorithms offer a novel dictionary learning approach that takes the graph topology into account. In fact, our algorithm learns the Laplacian of the graph while learning the dictionary. This work touched both the core modeling and the applications, and these are the papers related to this project. What I have just presented relates to my own team's efforts. As you can imagine, many excellent researchers all over the globe are working on different facets of SparseLand as we speak. The topic is hot and very influential. Indeed, all the top leading universities are in this game. We already mentioned this book, which our course is following with some omissions. If you are interested in more information on various topics we have discussed in these two back-to-back courses, this book could prove as a valuable source. Let's discuss the motivation to work in this field. You might be wondering, why are we doing all this? Well, each researcher comes with his or her own motivation. We are all in this in order to find new ways to process data, while being part of a vivid and friendly international community. Working in this field means being involved in cutting-edge and exciting scientific research. We all hope to lead to better understanding of existing algorithms and pave the way to new horizons. Many of us come with a strong mathematical curiosity, and as you have seen, this field is loaded with deep mathematical ideas. And then again, some of us just do all this for fun, a lot of fun. That's it. Welcome to SparseLand. If you are here with us, it means that you have survived the entire course. So we are delighted to award you with a formal citizenship of SparseLand. And hey, don't forget, you're family now. We hope you have enjoyed our course. We will be happy to hear from you with the feedback.